Okay, first thing I want to see function 2 and function 3 on your desks now. This is a homework check. And stop pretending to look if you know you don't have it.
No, I think I have it though.
Oh, you guys actually did some. I'm proud of you, period 7.
This is 3.
I know.
Oh, wait.
You had the whole weekend! Don't even walk over there.
Yeah.
Oh, it's on there.
Oh, it's down.
That's been obsolete! You tried to take me off! That's been obsolete!
I wasn't.
Oh, now I know when it's alright on the border where to put the cut, yeah.
Oh, wait a minute.
You know, like, when sometimes people are so close to the border, so I give them pity. But then, sometimes I don't give them pity, because it depends who they are. Some of you have built up a reputation. Good or bad. All right. Okay, so function 2 and 3. And then function 4, who knows what's going to happen in this class? But function 4, we're going to discuss it. Monday's not a holiday, right? No, so we discuss function 4 on Monday. We've gone to too many plan Bs already in this class.
What are we doing Wednesday?
Bonus points day? Okay, no, let's go over function 4 on Wednesday.
No.
No bonus points! Cam? No, we don't want bonus points. We want to do function 4, yeah! Okay, so function 2, 1H. Aren't you serious? Oh, very good. Finally, we figured out 1G. This is the first year then. 1H. Okay, what do you do when you see absolute value? A, pretend it's not there. B, skip to the next problem. We went through this already. Or C, write a piecewise function. You should be trained already. You should be thinking piecewise function already. So what are the two pieces? When the inside is positive and when the inside is negative, right? If the inside is positive, you leave it alone. If the inside is negative, you negate it. Okay, so let's simplify this. If this is f of x, what is f of x plus f of x all over 2? Just f of x, right? And what is f of x minus f of x over 2? 0. So you write the piecewise function. Or you can just do it in your head, I suppose. Now, what was the graph I gave you? It looks like this. I'm not going to draw it accurately. Okay, so what does this mean? What does this mean? F of x is like y. If y is greater than or equal to 0, tell me, where on the graph is the y-coordinate greater than or equal to 0? Where are the y-coordinates greater than or equal to 0? On the x-axis and above. So if the graph is above the x-axis, you don't touch it. You leave it alone. It stays f of x. However, if the y-coordinates are negative, that means when the graph is below the y-axis, the x-axis, what? You graph y equals 0. What is the graph of y equals 0? A horizontal line like this. So the graph is like this. So tomorrow, if I change that to a minus sign, all hell's going to break loose. I guess all hell's going to break loose then. And then, oh, very good. You know how to graph inverse. And I just want to make one comment about I, since nobody's asking. How come I said graph the inverse of y equal f of x? Why didn't I just say graph y equal f inverse of x? You guys know that symbol means inverse, right? Not 1 over. It means inverse. Why did I say this and not, why didn't I just write this? Mason, redeem yourself.
Is it because it's not like a function?
Exactly. Because when you graph the inverse of this, it's not a function, right? It doesn't pass the vertical line test. So that's why I had to say this. Graph the inverse. I have to say it in words. Because this notation is only for functions. And what did we learn last year? If you want the inverse to be a function, then the original function has to be 1 to 1. Does that sound familiar enough?
Can we do that one?
Even though it's not on the board.
Yeah.
You've gotta be kidding me. Graphing the inverse is for babies. Okay, here's your original graph. 1, 2, 1, 2, 1, 2, 3, 4. So, uh-oh, I graphed it wrong. Okay, so what I would do is I would look at some key points on the graph, like here. What is that? This is just me. -2, 0. This is 2, 2, and this is 4, 0. In fact, this is how I would probably graph all the graphs. I don't know how you guys did it. Okay. Now, if you want to graph the inverse, let's do this in a different color. What's the fastest way to graph the inverse? Switch the x's and y's. So, -2, 0 becomes 0, -2. 2, 2 becomes 2, 2, and 4, 0 becomes 0, 4, and then you connect the dots. There you go. And what did we learn last year? Anytime you graph any graph at its inverse, they will always be symmetric about the line y equal x. That doesn't even come out yellow. Okay, and are they? Yeah, see how the blue graph is not a function? That's why you can't use that notation, because it's not a function. Okay, so what was the problem with that one?
It makes sense now, yeah.
Switch to x's and y's. That's what I'm gonna do. Okay, number 2, C, F, and G. What? Okay, now when you do number 2, did you guys make a chart? Like if you make a chart, to me it's so much easier. Yes or no? Made a chart or not? No. So when you see this problem, okay, tomorrow you're gonna see this again, okay? So what do we got? 0, 1, 2, 3, 4. Okay, F, which one is F? It says f of 0 equals 2, so f is that one over there. So the y coordinates of f are what? 2, 2, 2, 1, and 0. Did I do that correctly? Of course, I'm the teacher. And then what are the y coordinates of g? 1, 2, 3, 3, 2. See, if you have a chart like this, so when you graph like f plus g, then all you gotta do is add the y coordinates, right, for each x coordinate. You know what I'm talking about? Doesn't that make it easier? And for the 3 clowns over there, never even do it. Why are you looking away? That's you. 3. So like when you do f plus g, look, you just add the y coordinates. See, 3, 4, 5, 4, 2, and then you just plot those points. You know what I'm talking about? It's way easier to do it like that. Here, so I'm doing 1a for you. 1, 2, 3, 4. 1, 2, 3, 4. So I guess we need 5. So 3, 4, 5, 4, 2. And you just go, just connect the dots like that. That's why you make a chart like that. It makes life so much easier. Okay, however, now what happened? C. Oh, what happens when you get f times g, however? F times g. Oh, that's easy, Mr. Park. You just multiply them. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 1 times 3 is 3, then oh, you think it's easy, huh? Okay, what's the question about this problem? 1, 2, 3, 4, 5, 6. Obviously, there must be a question. Okay, let's plot the points. 2, 2, 4, 6, 3, where's 3? 3, and then 0. And then just connect them with straight lines. Well, some of them, but not all of them. See, this is where you gotta know something. Okay, let's draw the two graphs. What's F? This is F. Toga, toga. And then here's G. Darn it, I missed it. That other line faked me out. Okay, here's F. And here's G. G goes like this. Juga. Uh-oh. No. It goes juga, juga, juga. Yeah. Okay, so this one is F, this one is G. Okay, now from 0 to 1, in fact, from 0 to 2, you're going to connect it with a straight line. Why? Because look, what is F? Like if you had to write the equation of F right there, what is that? What is that equation? It's a horizontal line. Nothing's easier than a horizontal line, people. That's y equal 2, right? What's the equation of this? X plus 1. When you multiply 2 times x plus 1, in other words, a constant times a linear function, don't you just get another linear function? It's going to be a line. That's why you connect it with a line. So anytime, see, like f is 2 here, and you're still multiplying it by x plus 1. So constant times linear is going to be linear, so that's why you connect it with a straight line. Now, what about between 2 and 3? Now, f is linear, but now g is constant. And again, you're going to get linear, right? Because what's the equation of this? 3. What's the equation of that?
1 minus x.
What? No. Negative x, the slope is negative 1. Negative x. This is a line, people. Negative x, Katamoto. Redeem yourself. Just read it off your paper. Yeah, right.
Minus 1.
Plus 4. Look, if you continue the lines, the y-intercept will be 4. What? And if you multiply it, you get what? Negative 3x plus 12. That's a line. However, what about between 3 and 4 though? See how you have, that's a linear times a linear. What happens? Okay, in fact, what's the equation of this one? Katamoto, redeem yourself again right there. The slope is negative 1.
No. No, I was talking to myself there. Sorry.
Is this a normal occurrence?
I need to like write it down on my.
No need, look, okay, look. Here is the point 4, comma 2. If you plug in 4, you gotta get 2.
So that's 6.
Okay, plus 6. And then this one we already established is negative x plus 4. So what happens when you multiply a linear times a linear? What are you gonna get? Quadratic, which is a parabola. That's why from here to here, it's curved, it's concave up, it's a parabola. How did I know it's concave up and not concave down? Because when you multiply this out, you get x squared minus 10x plus 24. The leading coefficient is positive, the parabola is opening upward, it's concave up. Oh, so Mr. Park, this is more complicated than I thought. Yes. So tomorrow, when you do this problem, I'm looking to see, like, do you have a straight line segment where it's supposed to be, or do you have a curve? And if you have a curve, is it correct concavity? See how it's concave up and not concave down? So that's what I'm looking for tomorrow. So first page, I'm gonna have 4 graphs, just like number 1 there. It'll be just like number 1. And then on the back page, the next 2 problems gonna be just like these right here. And then the last 2 problems gonna be from function 3. There, I told you the whole quiz.
Can you repeat that?
No.
From the video.
Oh, yeah, okay.
Well, maybe if you did your homework, I would wanna help you. You have the whole weekend. And nobody better help him either. Those 3 guys there, nobody helped them. They can watch the video again. Okay, and what are we doing next? No. Oh, so we can We don't know how to do C, but we can do D. That is so strange. I can't believe that. I cannot believe that. Okay, so we're moving on to F. Oh, and so we can do E even. Wow. You sure? No. I'm looking at Lam.
I figured because D is the same thing as C but different.
No. But that's divided. Did you notice that on problem E there's a vertical asymptote?
Yeah.
Where did that come from? So no need to E then.
No, we do.
Okay, D and E. Okay, D and E are similar because they're both dividing except different. Okay, let me pick the problem then. E. You want me to do E? Believe me. Okay, you want me to do it. Okay, E is G over F. So what you do is you take the y coordinates of G and divide it by the y coordinates of F. So do that. 1 divided by 2. 2 divided by 2. 3 divided by 2. Oh, I'm defined. 2 divided by 0. Oh. Yeah, but why is there a vertical asymptote there? 1, 2, 3, 4. Okay, here we go. So plot the points. Half, 1, 3 halves, 3, and nothing. It's undefined there. Okay, so do I connect it with a straight line or a curved line? Well, that's why you have to, okay, between 0 and 1, what is F? We're going G divided by F. Okay, what is G? Linear, right? What is F? Constant. If you have a linear divided by a constant, isn't that still linear? It's still a line. So, yes, line. In fact, same thing here, because look, G is linear, F is still constant. So when you divide, it's still going to be linear. So right there is a straight line from 0 to 2. Okay, but what about from 2 to 3? Well, what is G? What is G? No, this is G. G is constant, and then you divide it by F. Oh, what kind of function is that? It's called a rational function. Anyway, it's not linear, so it's not a line. So now, curve. It's got to be a curve there. Now somebody tell me, why, as you get closer and closer to 4, why is there a vertical asymptote there? Now, I'm not even sure you guys even know why there's vertical asymptotes. What did you guys learn last year about vertical asymptotes? Why is there a vertical asymptote there? Just because my teacher said it is. Yeah, no, but why though?
We undefined.
Because the denominator is getting very, very small. 11th graders, you guys gotta step it up. Only the 10th graders are answering the questions. Because look, you're taking the y coordinate of G and dividing it by F. Okay, look. As you get closer and closer to 4, like right here, let's say at 3.9, what is the y coordinate of G? At 3.9, what's the y coordinate of G? We're not doing anything until we get it. Okay, look, the y coordinate is 2 here. The slope is -1. So what do you think the y coordinate of G is right there? 2.1. And then you divide that by the y coordinate of F, which is 0.1. The slope is -1, people, it's easy. So what happens when you take 3.9 and you divide it by 0.1? You get 39, it gets really big. And then what happens if you get even closer? What about at 3.99? What's the y coordinate going to be? Why did it take 3.9? 2.1, fool. 2.01 divided by 0.01, what is that? That's 201, it gets even bigger. So when you keep dividing by a smaller and smaller number, what happens to the y coordinate? It starts getting really, really big. So the closer and closer you get to 4, the y coordinate gets bigger and bigger and bigger, and that's why there's a vertical asymptote there. You guys should have learned this last year. Okay, and then, oh, look at the time. We're just in a heap of trouble, yeah. The hole is just getting deeper. That's what's happening. Mom. And then F. Okay, come on, man. F. F is F squared. Are you kidding me? All you gotta do is square all the F values. So that's what? 4, 4, 4, 1, 0. Are we really going through this charade? I guess so. Nobody's stopping. 1, 2, 3, 4. What do we need? 4. 1, 2, 3, 4. So 4, 4, 4, 1, 0. Okay, now we got the points, but again, I'm looking for, are you connecting them correctly? So right here, can I just draw a straight line?
Yes, yeah.
Why? Because look, F is constant. It's 2. 2 squared is 4. It just stays constant, right? Okay, however, this is linear, right? In fact, the equation is negative x plus 4. What happens when you square it? You get quadratic, which is a parabola. So from here to here, it should be concave up, right? Because the parabola is opening upward. See, that's all you gotta think. You guys can handle that, right? And then G. So we are continuing this charade here. So G is 1 over F. I'm just gonna make it there. So all you do is you take the reciprocal of all of these numbers. So what do you get? Half, 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 1, and the reciprocal of 0 is undefined. I'm just gonna draw it on the same graph over here. Let's just do it in a different color. So half, 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 1, and undefined. What does that mean, undefined? Probably there's going to be a vertical asymptote there. So, again, F is constant. So, remember it's 1 over F. What is 1 over 2? 1 over 2 is constant. So, all along here is constant. But then what happens over here? You're taking the reciprocal of negative x plus 4. What is that? That's a rational function, right? It's not going to be straight, so it's going to curve. And then, wow! How come? Why is that a vertical asymptote again? Why? Because the y coordinates of f are getting closer and closer to 0. When you divide by a number close to 0, you get a really big number. And that's why there's a vertical asymptote there. Anyway, did you guys look at the answers and go, oh yeah, now I can figure it out. Did you guys even look at the answers? Kang? What answers? I didn't even look at the problems. Hard to look at the answers when I don't even look at the problems. That's shameless. Don't worry, Mr. Park, I don't clutch up tonight. And then what about the homework? Is everybody going to get 20 out of 20 on that homework? The bin absentee. Because as soon as bonus points day is over, I'm going to sit down and grade that homework. No! You guys got something to hide? I gotta grade at least one homework in the quarter, right? I didn't grade anything yet. You almost got 100%. Oh, you actually thought you got 100% because you earned it. Well, that is not the case. You guys, some of you are getting away with moida. Okay, now we are on, okay, we got 10 minutes left. We're in trouble. Function 3, 1D, oh, here we go. So this is where you gotta know how to do things to the graph. Now, I'm not sure if this is gonna be on the quiz, but this is definitely on the test, okay? Which is next week. No. How many functions are there? 4, yeah? Got 4 and then a practice test, so probably Wednesday or Thursday. Okay, so we got f of x is equal to 1 minus x squared. Now remember, I told you this is a base graph. What is this graph again? Ma. Told you guys this. This is a base graph now.
Oh.
You're not mom. Oh, so that's why you didn't remember to do homework. This is a semicircle.
Oh yeah, that's right. I remember.
As soon as I say it, yeah. Semicircle of radius 1. What if that number's a 9? Then the radius would be 3, right? Okay, so what are we trying to do? 1C, the mouth. Okay, so I am not going to do all of them. If you cannot do A and B, just go home already. That's look that okay? No, I'll do it. No, I'm going to do it. I am doing it. How do you know the thing is hard if you don't even try it, Paige? Oh, so Paige is in the same boat then. We got a boat. We got Kane, Kanemoto, and Ma. But now Paige wants on. Anybody else is on this boat? Lynn, are you on this boat? Lynn, there's no room for you. You just hang on to the rope. Hang on to the rope and get dragged to the boat. Paul, are you on this boat getting dragged to?
Yes.
Okay, what are we doing? Oh, yeah, we're doing, okay, now look at, no, we're doing 1A. 1A and B are the same thing except different. 1, 2, 3, okay, here's the, okay, what do I have to do to this graph to get this graph? Look, it looks like a semicircle, but you stretch it, except now it's a half an ellipse instead of half a circle. Okay, so what has, look at, you know what the key thing is? Look at the point. This is the point 1, 0. Now it's 4, 0. Oh, the thing stretched horizontally by a factor of 4 then, right? How do you make a graph stretch horizontally by a factor of 4? What do I have to substitute for x for that to happen? 4x or x over 4? X over 4, because it's a horizontal stretch. And then look, this is the point 0, 1, but now it's 0, 3. So how do I stretch the graph vertically by a factor of 3? Right there, finished. That's how simple A was, people. And then B is exactly the same thing, except it got reflected over the x-axis. How do you make a graph reflect over the x-axis? You multiply the whole thing by -1. That's it. Aren't you glad we went over those? Okay, now smile. Okay, now look at the smile. Where's the smile? Okay, so you gotta look at these points. What are these points? This is 2, -1. This is -2. That's why you gotta label the key points so you can see what's happening. And this is the point 0, -2. So, look, what do I have to do to this graph to get this? Well, first, you gotta do all the stretching and shrinking first. See, I wanted to talk about the ABCAD thing. I don't think we're ever gonna get there. Because some of you have this thing engraved in your brain. BCAD, but actually it's ABCD. Because we looked at it in the other class, or was it this class last week?
Yeah.
So ABCD. But then remember I told you as long as A is done before C and B is done before D, it really doesn't matter. Okay, what do I have to do to this graph to get this graph? Well, first you gotta do all the stretching and shrinking first. So notice that you gotta stretch it horizontally by a factor of 2 first, right? So you start with this graph. How do I stretch it horizontally by a factor of 2? Okay, x over 2. So now the graph looks like that now, right? And what about, do I have to do any vertical stretching? No, because that's 1, right? And it's 1, so no vertical stretching. Okay, but Mr. Park, the thing is upside down, so yeah, so I need to reflect it over the x-axis. How do you make a graph reflect over the x-axis? You multiply the whole thing by -1. Okay, so now the graph looks like this. Yeah, but Mr. Park, it's down here, look, the center, instead of the origin, is at the point 0, -1. So, what do I need to do? You need to bring the graph down 1 unit. How do you make a graph shift 1 unit down? Yeah, just put -1 at the end, and there you go, that's your answer. And then the eyebrow, are we doing the eyebrows? No, let's do them all. Okay, look at the right eyebrow. Isn't that exactly the same shape as the original semicircle? So there's no stretching and shrinking involved. All you have to do, well, I guess it's his left eyebrow that we're looking. Okay, look at his left eyebrow. Instead of the center being at origin, what? It's now at the point 2, 1, right? So I have to shift the graph 2 to the right and 1 up. How do I make a graph go 2 to the right? What do I substitute for x to make it go 2 to the right? X minus 2 shifts it 2 to the right. How do I make it go 1 up? Plus 1. Okay, but Mr. Park, go an eyebrow on the left too. So how do I make both eyebrows come up? You put absolute value only on the x. That's this thing right here. Remember this thing? How does that thing work? See, you got the eyebrow. How does this thing work? What does this do? It erases everything to the left of the y-axis, but there's nothing there. And then you keep and reflect the remaining portion over the y-axis. That's what this does. So that's how you get 2 eyebrows for the price of 1 right there. You put, that's this, f of absolute value of x, which means substitute absolute value for x. And there you go, that's your answer. So you have to know what will do what to the graph. That's gonna, oh gosh, that's going to tomorrow's quiz. Okay, I'll just tell you right now. Okay, we don't have that much time, people, so we gotta minimize damage here. 6, B, and C. Are you kidding me? Apparently not. Okay, 6. Here is the original equation. Y equal x over x plus 2. 6b. Are you serious? How do you reflect the graph over the x-axis? I mean the y-axis? What do you need to do to reflect it over the y-axis? This. You substitute negative x for x right there. Wherever you see x, plug in negative x. That's it. That's your answer. Simplify it if you want to multiply top and bottom by negative 1. Okay, C. It says, reflected over the line y equal x. How do you reflect the graph about the line y equal x? We just talked about that 20 minutes ago. Finding the inverse. So how do you find the inverse of that? You switch to x's and y's, and then solve for y. You guys can solve for y, right? Or do I need to do it? What? Wait, is it, you just want me to do it so you can copy, or you can't do it?
No, we can do it.
No, you're saying do it.
No.
That's what you're saying. You're saying do it.
No, the thumbs up means we can do it.
That remains to be seen. We'll find out tomorrow then. Okay, yeah.
Could we do
Negative f of negative x. Well, this reflects it over the y-axis and then reflect over the x-axis. That's not the same thing as reflecting it over the line y equal x. Reflecting it over the line y equal x means find the inverse. Let's leave the boat up there. Look, you can drag by your head. There's only a head there. And then number 7. Can we squeeze this one in? Okay, this problem is on tomorrow's quiz. I'm going to give you something like this, and I'm going to tell you to do stuff to it. Okay, it says first, stretch it horizontally by a factor of 2. How do you make a graph stretch horizontally by a factor of 2? Isn't that this? So substitute x over 2 for x. Wherever you see x, substitute x over 2. And that's going to stretch it. Now, you want to simplify all at once at the end, or you want to simplify as you go? Like, I'd rather simplify as I go. Well, too bad, I'm doing it my way. Multiply top and bottom by 2 to simplify. So x plus 2 over x plus 4. Okay, next it says, stretch it vertically by a factor of 3. How do you stretch a graph vertically by a factor of 3? Yeah, you just multiply the whole darn thing by 3. So, just multiply the whole thing by 3, like this. Wow! And then you get 3x plus 6 over x plus 4. You know what some people said last year? Don't you distribute the 3 to the bottom too? No, because 3 is 3 over 1. No, I'm serious. Okay, next it says, translate it 2 to the left and 1 down. Come on! How do you make a graph go, what did it say? 2 to the left. X plus 2, and then 1 down, minus 1. So what you need to do, substitute x plus 2 for x. So wherever you see x, substitute x plus 2. That will make it go 2 to the left. And then to make it go 1 down, you just minus 1 at the end, right? And then I will leave it simplifying to you. You have to know what will affect the graph. So pretty much that's like the whole quiz tomorrow, yeah? You gotta know what affects the graph. And then like you gotta be able to do this. Yeah, pretty much it's the quiz, right? The quiz is like the homework problems with different numbers. Okay, so this is the plan. We only got 1 minute left, less than a minute left. This is the plan. So tomorrow I'll get a quiz. I'm not gonna give you the whole period like last time. That's just ludicrous. So we're gonna talk about function 4 because we're gonna discuss that on Monday. And then, if you wanna know what you scored on the quiz, you gotta come see me Wednesday morning because all classes are being held on the tennis court on Wednesday. It's bonus points day. That means you gotta bring somebody's gotta bring at least one tennis racket. Okay, I'll bring one. I'll bring one racket. But if you want to play like 6 against 1, you gotta have 6 rackets, right? Or if you want to play 2 against 1, you gotta have at least 2 rackets. Yeah. Anyway, there's gonna be a sign on the door that says bonus points day, meet at the tennis courts. So you got 4 classes. Just think about it. I'm an old man. By the time you get to period 5, I'm gonna be really tired. Because I have to play 4 PCH classes and 1 AV class.
So we're warming you up.
No, I can't.
Really
I can only last. I-
Yeah, let's just
Where's Nate?
That's a good one.
hopefully you do better than last year.